All right, welcome back to the Explainer. Today, we're breaking down a huge, absolutely foundational math lecture from the ACE CBSE Class 9 and 10 AARAMBH batch. We are diving deep into the number system, and we've got some truly mind-bending concepts to unpack from their latest lesson. So get your notebooks ready, because we are going to master everything you need to completely crush this topic in your exams.
Okay, so picture a standard number line in your head. Got it? Now zoom in on that tiny little space right between the number 1 and the number 2. How many numbers do you think actually exist in that gap? I mean, you might immediately think of 1.1, or maybe 1.01, or even 1.001. But if you were to look through a microscopic lens at that number line, just how many individual numbers are hiding in there?
Well, here's our roadmap for today's Explainer. To find out, we're going to look at infinite density, prove the concept, learn how to find these hidden numbers, break down some decimal rules, and then tackle some actual CBSE practice questions.
Let's jump right into Section 1, Infinite Density. To really understand our mathematical universe, we have to talk about the density of rational numbers. Basically, the rule states that between any two rational numbers, there are infinite rational numbers. They are densely packed in there with absolutely no gaps whatsoever. Think of it like a really crowded room, but no matter how tightly people are packed together, you can literally always fit an infinite number of people between them. In the math world, there is never ever an empty space between two rational numbers. If we look closely enough, there's always more to find.
So getting back to that first question, how many numbers live between 1 and 2? The answer is literally infinity. And this isn't just some cool math trivia, right? It's a highly actionable concept that forms the entire backbone of how we handle fractions and decimals on your exams.
Moving on to Section 2, Proving the Concept.
Now, you can't just write, "it's infinity" on a CBSE exam and call it a day. You got to prove it. Here is the exact logic you need. First up, remember this golden rule. Rational numbers are closed under addition and division. That just means if you add two rational numbers or divide them by a non-zero integer, the result is always going to be another rational number. So if we take two numbers, let's call them a and b, their midpoint, which is just a plus b divided by 2, has to be rational too. That means this new midpoint sits perfectly right between them. So a is less than the midpoint, and the midpoint is less than b. And because we can repeat this exact same process forever with the new midpoints, boom, we've just proven infinite density.
All right, let's roll into Section 3, Finding Hidden Numbers.
So, how do we practically find these hidden numbers when we're actually sitting in the exam hall? Well, you've basically got two main tools in your toolkit. Method 1 is using the average, and that's perfect when you just need to find a single rational number. Method 2 is multiplying the numerators and denominators. This is your heavy lifter. It's exactly what you want when a question asks for 3, 5, or even 10 rational numbers all at once. Knowing which tool to pull out will save you a massive amount of time.
Let's test drive that average method first. Say you're asked to find a rational number between 3/5 and 7/5. We start by just adding them together. Since the denominators are the same, that gives us 10/5, which simplifies down to 2. Next, we just divide that by 2 to find our average, leaving us with a nice, clean midpoint of 1. Making sense so far? It's the exact same logic we just used in our proof.
But what if the exam throws a curveball and asks you to find 5 numbers between 2/3 and 3/4? That average method would take forever, right? That's where method 2 comes in. First, we make the denominators equal. The lowest common multiple of 3 and 4 is 12, so 2/3 becomes 8/12, and 3/4 becomes 9/12. But hold on, there are no integers between 8 and 9. To fix that, we simply multiply both the top and bottom by a common integer. Let's just use 10, because it's super easy. Now we have 81/20 and 91/20. And from there, you literally just pick the numbers. 81/120, 82/120, 83/120. You've just unlocked a whole range of numbers without breaking a sweat.
Shifting gears now to Section 4, Decimal Rules.
You know, fractions and decimals are basically just two sides of the same coin, right? When we convert these fractions, they are always going to fall into one of two categories. First up, terminating decimals. These are decimals that actually have an end. So 1/2 cleanly becomes 0.5, and 3/4 becomes 0.75. The division just stops. On the flip side, we have non-terminating recurring decimals. These guys go on forever, but they repeat a clear pattern. Think of 1/3, which becomes 0.333, and it just keeps going to infinity.
And here is the absolute ultimate cheat code for your exams.
Listen closely because you literally do not need to do any long division to figure out what type of decimal a fraction will be. All you do is prime factorize the denominator. That's it. If the prime factors are exclusively 2s or 5s or a combination of both, it is 100% guaranteed to be a terminating decimal. But if there's even a single other prime factor in there, like a 3 or a 7 or an 11, it will definitely be non-terminating recurring. Honestly, this trick is a total game changer for saving time.
Time to put it all together in Section 5, CBSE Exam Practice.
You've got the theory down, you know the shortcuts. Now let's test your skills. Here is challenge number 1. Without actual division, classify the decimal expansion of 7/8. I highly recommend you pause this explainer right here, grab some paper, and try to solve this yourself first using that trick we just went over.
Okay, let's see how you did. So, completely ignoring the numerator, we look strictly at the 8 down in the denominator. Prime factorizing 8 gives us 2 times 2 times 2. And because these factors are exclusively the number 2, our rule guarantees this is a terminating decimal. See? No long division required at all. Let's do one more. This one's a conceptual question that loops right back to the beginning of today's explainer. Is the midpoint of 1/4 and 1/2 a rational number? Think back to that theoretical proof we walked through earlier.
And the answer is an absolute yes. Remember, rational numbers are closed under addition and division. If we calculate the actual midpoint by adding 1/4 and 1/2, which gives us 3/4, and then dividing that by 2, we end up with 3/8. Since 3 and 8 are both integers, 3/8 is definitively a rational number. The universe of rational numbers holds up no matter how tiny that gap gets.
You guys did awesome today. We covered infinite density, midpoints, and some seriously powerful decimal shortcuts. The original ACBSE lecture has detailed class notes linked down in the description box, so definitely make sure you grab those. If you found this explainer helpful, go ahead and hit that like button and subscribe. But before you go, let me leave you with this one thought. If the number line is completely, infinitely packed with rational numbers, leaving absolutely zero gaps, then where on earth do irrational numbers fit in? Keep thinking about that one, and we'll see you in the next explainer.